Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 7G. My name is Alicia Mullah, and I will be your moderator for today's session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Bangkok, Thailand, and the virtual event is being held on Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for today's session. Dr. Sanjay Agal is a professor and head of Department of Artificial Intelligence and Data Science at Parallel University in Gujarat, India. His research areas include artificial intelligence, data science, machine learning. He is actively involved in teaching, research, departmental leadership, and academic development in advanced computing domains. Dr. Sanjay, I would like to request you to please say a few words.
Thank you, Alicia. Good morning, everyone. Myself, Dr. Sanjay, and as I have seen the list of presenter today, we have variety of domains going to present. And before going for presentation, I would like to share few things about me. I work basically in financial domain as well as data science and machine learning. Interested in looking forward for the content which is quite written in the format with all the technical guidelines fulfilled as well as all the preliminary ethical guidelines have fulfilled. Domain is important as well as presentation is important, and not only presenters, I request to each and all audience here that please raise your question, ask your doubts of the presentation. So we will have fruitful discussion because an international conference has one main objective is to have major contribution of audience. Presenter is always presenting the content, but the role of audience is most important. And being in session chair, I would like to talk to each and everyone. But one simple request, as Alisha already mentioned it, stick to your timeline. Give last 2 minutes to your audience to ask questions.
Thank you, sir. We may now begin with our presentations. Our first presenter for today is Mohammad Zaheb Ahmed, who will be presenting a methodology for LTO decision support in military aviation using rule-based modeling and synthetic data. Zaheb, you may now begin.
Hello. Hello.
Yes, you're audible.
I will take a few minutes as my PC is being updated.
Oh, okay, no worries. In that case, we'll move on to the next presentation. We'll circle back to you towards the end.
Thank you so much.
All right, so moving on, our first presentation for today would be Ritesh Kumar Verma, who will be presenting an adaptive retrieval augmented customer support agent with learning to rank using Azure ML and OpenAI. Ritesh, you may now begin. Is Ritesh or any of his co-authors present in the meeting? All right, in that case, we'll move on. Next, we have Abdul Rahman El Antabli, who will be presenting Balance, a dual judge framework for fine-grained hallucination detection in Arabic LLM outputs. You may now begin.
Yeah, thank you, Alicia, for the introduction. I hope I'm audible. All right.
Yes, you are.
Okay, I will start sharing my screen. Um, so, can you see my screen now?
Yes, we can.
Okay, perfect. Okay, so thank you so much. My name is Abdurrahman Al-Antabli. I'm from Egypt, and I'm here to present our paper Balance, a dual judge framework for fine-grained hallucination detection in Arabic LLM outputs. It's by me, Abdurrahman, Ali Hamdi, and Ammar Muhammad. This is the agenda for our presentation today. We will have a quick introduction about the topic. Then we will clearly state the problem statement and objective. Then we will talk about the previous studies that approached the same problem. And we will go through our proposed approach, which is balance. Then I will present some insights from the results, and we will end up having some points to conclude and to refer to future work. So first of all, we all know that LLMs have been demanding for the previous couple of years. We had explosive growth. For example, GPT reached 1 million users in just 2 months, becoming the fastest adopted consumer technology in history. And LLMs became a cornerstone in lots of real-world applications, not only in the research but in the industry. So it's actually adopted and deployed in lots of domains. And this is the architecture of the attention transformers that was the cornerstone of all the LLMs that we are using today. Okay, but despite LLM fluency, the problem is LLMs often generate factually wrong information, and this phenomenon known as hallucination. And the problem is the LLMs produce this wrong information with confidence and fluency, so we cannot distinguish between the correct and the wrong claims of the LLM. And this happens because LLMs always favor plausibility over truth. It tends to be plausible than being confident about the information. And the problem is they can snowball. We can have the LLMs can keep justifying their false claims, so the error keeps snowballing. And this affects lots of LLM applications like summarization, question answering, machine translation, and lots of applications of using LLMs. And hallucination happens due to multiple things, maybe noisy training data, and the parametric nature of LLM memory. So like it's a frozen model weights. It's not like the human memory trying to like recall things and so on. And the nature of LLMs is is likely to predict the most likely token. So these all are causes of this hallucination happens. Yeah, and the hallucination detection has been recognized as a critical challenge in NLP research since the early days of NLP generation or natural language generation tasks. But most of the studies focus on having detecting hallucinations on a sentence level, but we need like to detect hallucination in token or span level because a sentence may have correct and incorrect information. So we cannot judge about a whole sentence to be hallucination. Okay, this is an example about this. And the problem becomes more complex when we are talking about Arabic because Arabic is morphologically rich, one of the world most morphologically rich languages, and it lacks suffering from like scarce clean corpora along the internet or compared to English for sure. And studies show that Arabic produce 25% factually incorrect sentences in their outputs. So our problem statement here should be clear. LLMs often produce fluent but factually incorrect outputs that are hard to detect and localize at token or span level. And Arabic's data scarcity, rich morphology, and dialectal variation make these hallucinations harder to detect, and there is no widely adopted fine-grained detection approach for Arabic. Okay, I will go directly I mentioned lots of these related works groups in the like introduction, so I will go directly to the proposed approach to save time. So here we propose our approach here, which called balance by perspective analysis for LLM accuracy via consensus checking. And it uses like a dual judge consensus mechanism that balances between precision and recall in token level hallucination detection. So I will start to explain the methodology here in this graph. We have three inputs. We have a human question and a generated answer from a certain LLM, and we have a factual reference that holds all the true text. Okay. First process is like we use LLM to do context filtration. So we are keeping only the sentences that are relevant to the question and answer. Then the second part is argument decomposition. We are decomposing the arguments in the generated answer into atomic claims. Each claim is composed of like subject and predicate only. And then these claims goes to filtered context. These claims go to two judges. One is a strict judge, and one is a lenient judge. This strict judge, judge by explicitly seeing if that claim is mentioned explicitly in the context. But this lenient judge is more relaxed and depend on the meaning more than the explicitly mentioning the sentences. Then there is a coordinator coordinating between these two lenient judges, and then a span annotator that maps these wrong and correct claims to the generated originally generated answer to like have each token that is false or wrong claimed. Okay.
Excuse me, I'm sorry to interrupt. You have about a minute left.
Okay. So here I will talk here about the results. We are using the dataset that were subset of Arabic dataset in the mushroom SEM-Eval Task 3 2025, and we are using the same evaluation metric. This is an example of the data. So our results, we achieved intersection over union 72.87%, and this outperforms SEM-Eval Task 3 Arabic winner by 8.76%. And we consistently surpasses zero-shot baselines across multiple LLMs. So here, this is the top teams in the competition. With balance, we got a higher score. And this is a comparison between the performance IOU using zero shot plus context, and our solution balance. We can find that balance always increase the IOU relatively to zero shot and zero shot context. And this is applied to multiple LLMs, like we can see here. Okay, so as we mentioned, maybe our future work is to extend to other low resource morphologically rich languages like Chinese or something, explore automated correlation of detected hallucinated spans, not just detection, investigate lighter, more efficient backbone models to reduce inference cost because we are using multiple LLMs, so we have high inference cost. And we may evaluate our solution on domain specific settings like medical or legal or news. And this is a couple of references. And yeah, I'm done. Thank you. Questions, please.
Good morning.
Hello.
Yeah,
Good
here
morning.
Dr. Sanjay Agal.
I'm sorry?
Here Dr. Sanjay Agal, session chair for the session.
Yeah. Hello, Dr. Sanjay. How are you?
As I can see your references, there is no recent reference I can see of 2025, I guess.
Yeah. Yeah, there are no, I think, 2025 because there is one here, a
Yeah,
survey on LM hallucination.
there is a one. Okay.
Yeah, I'm not sure if there are other resources that in 2025.
Okay. I hope you have checked all the possible references of your work.
Yeah. Yeah, I hope so as well. I think because most of the papers published in 2025 were like under review or something, so I couldn't depend on them on the in the research here.
Okay. And what is size of your data set?
Okay, it's relatively small. It's about like 160 row.
Okay. Done from my side, Alisha.
Okay, thank you.
All right, thank you.
Okay,
Now we'll have our next presentation by Mohammad Zuhaib Ahmed, who will be presenting a methodology for LTR decision support in military aviation using rule-based modeling and synthetic data. Zuhaib, you may now begin.
Wait, I'm joining from my laptop.
Okay, all right. Are you ready to begin right now?
Yes, 1 minute.
All right. Zuhaib, you're not audible.
Hello, am I audible now?
Yes, you are.
Okay, is my screen visible?
No, I think you've stopped sharing.
Right. Visible now?
Yes, it is.
Okay, let's begin. So my research paper was on a methodology paper basically for LTO, which is basically lift and takeoff decision support in military aviation. Okay, so first of all, it is a rule-based modeling at this time, as we used an open source booklet of the rules used in military LTO aviations, and we generated a synthetic data using Monte Carlo simulations. First, let's take a look on the background and the problem statement. So, why a methodology is needed? So, operational challenges. There are multiple operational challenges during lift and takeoff in military aviation during critical operation, and the human error accounts for almost 70% of aviation incidents globally. Okay. During critical operations, the fatigue and the stress impair the judgment of the pilots. So, a data-driven decision tools is essential for protocol recommendations. And the second problem we faced was the data scarcity, as military aviation records are classified and the access is very limited or almost no access is granted. So, a structured pilot decision logs are unavailable for external research, and no label data training data exists in open source community. So, what's our research objectives? We identify and categorize relevant input factors for LTO decision making, and then we develop a synthetic data set using Monte Carlo simulation with location specific constraints. Then we formulate our rule-based expert system for operational status assignment. Then we develop and compare multiple ML models like linear regression, naive Bayes, SVM, and decision tree for LTO prediction. Then we propose a human in the loop HITL deployment framework, as any military aviation problem or military aviation operation is must be done under a human supervisor. We cannot fully rely on a completely autonomous system. So first of all, what are the input features we identified? There were 14 parameters that we identified, out of which 10 were weather and geophysical parameters and 4 were airfield stations. So as you can see, visibility is the primary factors which affects the LTO decisions, and the other weather and geographical factors that affect LTO decisions. Then we come to airfield stations. That what terrain is are we making a lift and take off, or are we landing? Then the altitude at which we are above the sea level that we are landing or taking off. Then the runway length. Then the PCN. PCN is basically the uh, measure of how much load a runway can uh, adhere. Okay, next slide. So, what was our research methodology? First, we identified the gap in this domain of methodologies for military LTO decisions. Then we identified the factors. Then we studied the locations. Then we generated the synthetic data using all the parameters and the Monte Carlo simulation. Then we used an open source aviation rulebook for labeling which conditions are green, that is safe, orange, that is caution, and red, that is unsafe. Then we use the ML model development, which we use for uh, linear regression, naive Bayes, SVM, and then decision tree. And we found out that decision tree was the best among all, which we will discuss in next slides. Then we moved on to evaluation and comparison. All the uh, all the parameters, all the precisions, all the accuracies, or F1 scores, and others. Then we moved on to explainability using SHAP and Guinea importance. Then we will go on to the HITL deployment framework. So how we generated our synthetic data using Monte Carlo simulation. We first selected the IF stations. Then we defined the location specific parameters like we took 5 terrains and 10 airfields. Like we took high altitudes regions, desert regions, forest regions, and plain regions, arid regions. Then two of each, that will make 10 stations. Then 2000 instances per station, that will make 20,000 records. Then we used NumPy and scikit-learn and Monte Carlo generation. Then we applied the geographical seasonal constraints and then the aircraft categories. Then we accumulated the valid scenarios using cosine uh, using cosine filtering. Then we repeated for all the 10 Air Force stations. Then we concatenated and the full synthetic dataset. Okay, so rule-based expert classification system was like green was for safe. Then we labeled which conditions were safe, which conditions were risky, and which were completely unsafe. Then here is a comparison of the ML model which we used. Here you can see LR, NB, SVM, and decision tree, in which decision tree performed the best. Now here's the feature importance, like which of the features are the which affects the most of the decisions. Here you can see the whole graph. It's in the research paper too. Then okay, now to the conclusion, the future work. This is, I think, the first replicable methodology for LTO decisions support under data scarcity, as no real data is available in the open source community, and as it is a methodology paper. And in the future work, we can integrate real pilot decision logs. Like we can take 10 pilots who will use a voting system that in certain conditions should we take off or land or not. Then we can use correlated sampling uh, and develop a framework for the decision supports in wargaming simulations or full support system in real aircrafts. Okay, that's all. Thank you, everyone. Any questions?
Hello, Sumit.
Hello.
Any study to verify your synthetic data?
Sir, we used real world parameters and
Hmm.
yes.
After generation of your synthetic data, how did you verify the generation was right or wrong?
Sir, this the data generation part was done by my seniors and my professors.
Obviously, but still they have shown you that we have generated this data,
Mm,
and they have might have shown you that this is the process, it is verified by this way.
okay.
Because if your Python code is not working proper,
Mm,
how do you know that data set is right or wrong? And you are saying it is a 20,000 instances.
mm,
So after generation, I'm not saying before what technology you use, what code you use. But once it is generated, have you verified it or not?
Sir, it was verified by my seniors.
What is the process to verify? That is, I am asking.
Okay. Sir, they used, I think, cosine similarity.
Okay. Thank you, Alisha. Thank you, Junaid.
Okay.
All right. We'll move on to the next paper now. So next up, we have Yui Pham, who will be presenting DBWiki VN15K, Vietnamese Multimodal Knowledge Graphs for Entity Alignment. Yui, you may now begin.
Can you hear me well?
Yes, we can.
Okay. Okay. Can you see my screen clearly?
Yes, we can.
Okay. Good morning, everyone. My name is Yi Phạm, representing my group from the University of Science, Vietnam National University, Ho Chi Minh City. I'm honored to present our paper, DBWiki VN 15K Vietnamese Multimodal Knowledge Graphs for Entity Alignment. So to give you a brief roadmap of today's talk, I will start with the background and the motivation of our research, leading into the introduction of our new dataset, the DBWiki VN15K. Then I will walk you through our construction pipeline of our dataset, and then provide a structural analysis of our data. Next, I will review our experiments with the results and our key findings. Finally, I will wrap up my presentation by discussing the limitation of the works and as well our plans for the future work. Knowledge graphs are widely used for structural knowledge presentation. Recently, research has extended them to multimodal knowledge graphs to improve the tasks like cross-graph entity alignment. On the other hand, entity alignment aims to identify equivalent entity across the heterogeneous knowledge graphs, allow us to enable the knowledge integration. However, existing entity alignment benchmarks such as FBDB15K, FB 50K focus just on the resource-rich language, only in English, and assume dense structures. Low resource language such as Vietnamese present a unique challenge, including a structural sparsity, inconsistent naming, and limited multimodal resources. To address this gap, we introduced our new dataset, DBWiki VN15K, which is available in this GitHub link. Our dataset is the first large-scale Vietnamese multimodal knowledge graph dataset for the entity alignment task. It is constructed from the Wikidata and DBpedia encyclopedia, containing 15,000 aligned entity pairs and enriched by the relational triples, numerical attribute, and images. To support a different natural language processing encoders, we provide two textual variants, an unsegmented version for the multilingual tokenizer like mbert, and a word segmented version for NLP encoders like Barbert, which I will explain later. Let's look at how we build this dataset. First, we initiate our data crawling pipeline by querying the Wikidata as par, PL, endpoint. Then we apply a strict seed selection to prioritize the entity with at least one with appear in at least one Vietnamese Wikipedia article and with at least one image, focusing on the heavily populated classes and Vietnamese-centric concept. To reach our exact target of 15,000 entities, we apply an iterative pruning algorithm to remove up to 5% of the lowest degree node at each iteration. to ensuring every entity remains structurally connected. Then we map the Wikidata entity with their corresponding DPpedia using the OWL CMS property. Finally, we query the DPpedia for the internal relations, numerical chipboard and image to yield comparable multimodal DPpedia subgraph for the entity alignment task with Wikidata subgraph. Next, the raw multimodal data from the previous step. We went through 4-stage automated cleaning pipeline to ensure structural consistency. First, we identify and filter out the often entities. Those entities have attributes and image, but appear in no relationship balls in our graph. They are removed permanently. Then we use a deduplication algorithm to merge the duplicate attribute, just keeping the most recent triple, the attribute triple. Then we remove all the entity alignment pairs with at least one of those are the offend entity from the previous step. And then we reindex the image so that every filter image will have zero index identifier. To create a truly localized benchmark, we apply a context-aware LM to translate unique relations and attributes. This allows us to generate two parallel textual variant dataset, an unsegmented version for the embedded and word segmented version for linking compound syllables for alphabet. For example, the word thành phố, which means city in English, must connected by a underscore for alphabet to use to tokenize. Then to ensure the models learn distinct relation embeddings without cross-graph interference, we prepare a namespace prefix db to on the db relations, and this ensures the graph relation remain disjoint between two graphs. This table shows our dbwiki VN 15K statistic. We can see that on the table that Wikidata offer a richer relational structure, while DBpedia containing substantial more numerical attributes. Both graphs include at least one image, and the CMS links define our entity pairs for the evaluation tagging between two graphs. So every entity in the DBpedia will connect to some Wikidata entities. Some structural analysis of our graph. Both graphs exhibit a highly skewed and long tail frequency distribution. Some entity and some relation type appear too frequent as compared to others. And the heavy tail degree distribution is also observed, where most entities have very low degrees and only a small number of entity connect to many others. And we can see the very high count of the number of entity on the left and very low, very small number of hub entity on the right. So this affects the entity alignment really hard. This forces the low degree entities to rely much more on the text and image, as well as numerical modalities rather than the relation, the graph structure itself for the entity alignment task. The same skew long tail distribution is also observed in the numerical attributes in DBpedia on the left image, left figure. Numerical attributes are biographical, such as birthday or death date. Wikidata feature focusing on physical and demographic like height, area, and population all follow a long tail distribution. We experiment. We have some experiment on four SOTA models. These models are proved to have a really high performance on no multimodal nurse graph like FBTB or FB-YAGO, DSR, MS-NIA, MIA former, CLAMIA, and SG-MIA. We use 20% ground truth links for training and 80% for testing. We examine those models with two distinct text encoder settings, an unsegmented, multilingual BERT, and segmented for BERT. Our experiment are conducted on cargo using the Tesla P100 GPU. Some hyperparameter was changed to match our hardware. For SGMIA, the bus size was reduced from 3500 to 2000 to prevent out of memory error.
Excuse
SGMIA.
me. I'm sorry to interrupt, but you have 1 minute left.
Okay. SGMIA and MIA from use ResNet 50 and other hyperparameter remain the same in the original implementation. This is the baseline performance of our experiments. We can see that SG MIA achieved the SOTA performance on our dataset, outperforming on others models by a significant margin. MIA Farmer also demonstrate a very strong performance. One key observation is that for CLAMIA, there is noticeable gap between the text encoder BERT and for BERT. When BERT yielding a better result than for BERT across all metrics. From that performance, we come up with some insights. SGMIA performance dominant. Is dominant thanks to it grab attention network, aggregate sparse neighborhood data, effectively encounter the dataset's structural sparsity. This enrich the visual and attribute modalities. For MIA formers, thanks to its dynamic modality weighting, it can downweight extreme attribute asymmetry and visual noise in our dataset. Between the FARBERT and BERT encoders, we can see that unsegmented subwork tokenization better handle the cross-graph translation inconsistency by the LM than strict binary word segmentation used by FARBERT. And our DBWiki VN encounter a structural skew in DBpedia, a large imbalance in numerical between two graphs, and overall relational sparsity also limits the traditional dense embedding methods. That's why some of the very SOTA models perform bad in this dataset. Future work should focus on reducing structural imbalance and developing multimodal entity alignment models to go to tailor for this asymmetric and low resource testing of the low resource language like Vietnamese graph. Thank you for listening. I'm happy to answer any question.
No question from my side, Alesh.
Okay, thank you.
All right. We'll move on to the next presentation. So next we have Ritesh Javarkar, who will be presenting Framework for Querying Database Using Natural Language. Ritesh, you may now begin.
Okay, hello, am I audible?
Yes, you are.
Okay, so just a second, I'm sharing the screen. Is my screen is visible?
Yes, it is.
Okay. Okay, so good morning, everyone. So I am Ritesh Javarkar from the Tamega Institute of Higher Education and Research from Maharashtra. Today I'm honored to present my research paper title, which is Framework for Querying Database Using Natural Language. So, basically, this research focused on simplifying database, which is accessed by enabling users to interact with database using natural language, like instead of complex query syntax. So, moving to the next line. So my presentation is divided into following sections. The first is introduction. After that, existing approaches, research gaps, and proposed methodology, result, and discussion. And then finally, conclusion with future scope. Uh, Moving to the next slide. Uh, in today's data-driven environment, organization generates a massive volume of structure and unstructured data. However, accessing this data often require knowledge of SQL or other database query languages. So, which creates a barrier for non-technical users. Natural language interface solves this challenge by allowing users to ask question in simple human language. So, this system then converts this question into a structured database queries. So before moving further, the next slide continues the introduction with the opportunity and objective of this research. So this research area has a strong opportunity demanding for user-friendly and uh, AI data driven, which is accessed by system. It is growing rapidly. So the primary goal is to enable seamless interaction with users and database, which is using with natural language. So the main objective includes translating users' queries into SQL and no SQL formats. Uh, with the help of this, we can improve the query accuracy and support multi-channel database systems. And To understand background of this work, let us now look at the existing approach. Okay, so existing research mainly includes rule-based system, statistical approach, and machine learning models and semantic matching techniques. So basically, rule-based system relied on predefined grammar data, and statistical methods identify the query, which is structured using corpus patterns. And then there is a machine learning models, which is improve flexibility and reduce the manual rule dependencies. So moving to the next slide, there is yes, problem in existing approach. So the major limitation in current system, it is include limited multi-channel support and high dependency on domain, which has specific rules, and it is a difficulty in handling ambiguous users queries, and it has a poor support for NoSQL and graph databases. So additionally, many machine learning system require large level data sets. I think which the these are expensive to prepare. Uh, this limitation reduce scalability and practical adoption in real world entire system. So moving to the next slide. The There is a proposed methodology. So the proposed framework combines natural language processing and there is machine learning and semantic query understanding. It has a hybrid architecture. So the process begin with user provides. It is a natural language query. Uh, Next, semantic mapping aligns the extract intent with target database schema. So on the base of the that schema type, so this system dynamically translate the query into a relational database, which is for SQL. Okay. Uh, then after designing this framework, the next step was to analyze the comparative performance. So yes, there's yeah. So comparative analysis indicates that approximately there is a 70% of existing framework focus on SQL query translation, while there is SparkQL contributes around 15%, and Cypher is 10%, and the Journaling is 5%. So this clearly shows that SQL-based system dominates the current research due to maturity. So, like at the same time, it also highlights a significant research opportunity in NoSQL, and there is a graph database. So, this findings strongly support the relevance and future potential for the hybrid framework. So, yes, there is a next slide, which is conclusion and future work. Uh, In conclusion, there is a natural language interface which is simplify the database for non-technical users. Like while current frameworks are large SQL centric, there is, I think, there is a strong scope for extending this system towards the NoSQL. So the purpose hybrid framework, it will improve the semantic understanding and flexibility and real world applicability. So as per future work, this research will extend using deep learning and transformer based multi transformer based models and context aware conversational syntax, sorry, system. So yes, then this is the reference. Uh, yes, thank you. I'm done. Thank you for everyone for your kind attention. Any questions or suggestion, please? Hello.
No question, Alex.
Okay, thank you.
All right. So moving on to the next presentation. Next up, we have Aman Kumar, who will be presenting hierarchical federated learning for privacy-preserving intelligent content delivery networks. Aman, you may now begin.
First of all, good morning, everyone. Let me share my screen. So my screen is visible.
Yes, it is.
Okay. So, good morning, everyone. My name is Aman Kumar, and today I am presenting my research on hierarchical federated learning for privacy preserving is intelligent content delivery network. This mainly focus on improving the CDN performance while ensuring data privacy using federated learning. So my next slide is uh, in this presentation, I will cover introduction, problem statement, literature survey, methodology, system architecture, results, and the conclusion. Coming with the introduction part, content delivery network or CDN are used to deliver content like videos, web pages quickly using distributed edge servers. So traditionally, system was a centralized machine learning where all the users is sent to be a central servers. This causes privacy risk, high communication costs, scalability issues. Also, real-world CDN data is non-IID and heterogeneous, making centralized learning efficient. So, to resolve, we use federated learning, where data stay at the edge nodes. Only model parameters are shared. So, this improves the privacy and reduce the data exposures. So next is my problem statement. The main problem of existing CDN systems are centralized data collection, which issue privacy risk, high communications overhead, traditional caching in LRU and LFU not adaptive. We use the non-IID data, reduce performance, need for a scalable and secure solutions for the CDN systems. So we aim to design privacy preserving intelligent CDN system. This is my literature survey. Previous research has used federated learning, deep reinforcement learning, but they have the limitations of high complexities, not designed specifically for CDN, high competition cost, limited focus on privacy. So there is a gap for simple, scalable, and secure federated-based CDN systems. So the research objective is of my research is build a secure federated learning model, preserve user data privacy, handle non-IID data, compare. I had compared centralized versus federated learning model, reduce the communication cost, and maintain the high accuracy. So this is my architecture, system architecture, where edge nodes are trained in the local training and reason aggregates. Immediate reasons are trained in the intermediate aggregation. Cloud servers are locally trained in global model. The process is mainly each edge nodes trained locally, sends the updates to the local models, and server aggregates uses the federated average. So no raw data is shared to ensure the privacy. This is the proposed architecture where our methodology includes data processing at edge, non-IID data partitioning, local neural network training, secure aggregation with noise, performance and privacy evolution, continuous federated learning cycle. So this is my proposed methodology here. And the model process where the steps are global. Firstly, global model is initialized, local training at the edge nodes, where the models are updates and generated, secure sharing of the parameters, where only the model updates the transmitted to the central server, often with the security mechanism such as masking and noise addition. Then the aggregation in the model fed average, where the central servers are receive the updates using the federated algorithm to process to improve the global model and secure the data. Lastly, we uh, iterate the learning process. The process is relatively multiple communication rounds until the model convergence and achieve the optimal performance. And this is my privacy where the centralized learning is at high risk and federated learning stay local and secure. The proposed federated framework ensure strong privacy prevention compared to centralized learning. This is the conclusion of the project where the federated learning preserve privacy, uh, achieve the performance similar to centralized, reduce the communication, handles non-IID data effectively, improve the scalability, where the systems effectively handles heterogeneous edge data distribution for securing the convergence of the multiple communication rounds. Um, the scope of my project is for the real world CDN deployment, multiple cloud systems. The system integrate with privacy preserving mechanism where the aggregation, noise masking, and the noise injection is reduced to data leakage risk. Uh, the minimize the raw data transmission between the edge nodes and the central servers. They're improving the confidentiality of the regulatory compliance. It integrated with the AWS with the edge devices. Thank you.
We can move to next, Alisha.
All right.
Ma'am, good morning, ma'am. Ma'am, when my chance will come, Ritesh Kumar Verma.
We'll be taking you at the end of the session.
Hello.
Hello? Yeah, we'll be taking you at the end of the session.
Okay, thank you.
All right.
Excuse me, ma'am.
Yes.
Dr. Sanjay, hello.
Yes.
You asked a question about how we. My paper is the LTO decision support one. So you
Yes.
asked the question about how we verify this generated data is correct or not. So the answer was I asked my professor. It was Guinea and SHAP feature importance.
Pardon, please.
Hello.
What did you say in the last line?
We analyzed the correlation matrix and then we did the Guinea and SHAP analysis to verify whether the generated data set was realistic or not.
But correlation matrix with whom? There is no open source available. There is no confidential data publicly available. So correlation with which data?
Sir, with actual aeronautical physics, like whether the like when we generated the data, it was aligning with the real aeronautical physics.
Yeah, but there is no real world data available publicly to any audience. That's why I'm asking, how did you prepare your correlation matrix? It's okay, no issue. Just tell your professor that go for the ablation study
Mhm.
and add in the paper if possible in future whenever you are doing anything with synthetic data.
Okay, sir.
All right. Our next presentation for today is by Bambang Marsuti Salim, who will be presenting IDA star search for event reconstruction in falsified forensic timelines. You may now begin.
Hello, can you hear my voice?
Yes, we can.
Can you see my screen?
Yes, we can.
My name is Bambang Marsudi Salim from the Department of Informatics, Institut Teknologi 10 November, or ITS, from Indonesia. I will represent our paper titled IDA Search for Event Reconstruction Falsified Forensic Timelines. This paper is co-authored with Dr. Hudan Studiawan and Dr. Baskoro Adi Pratomo, founded by Equity Program LPDP. Computer logs are the primary evidence in digital forensic investigation automated records of the system activities with timestamp. The problem, an adversary can manipulate these logs before handing them investigator. Three methods deleting important, altering timestamp, or injecting fabricated entries. Tang and Fitch in 2010 proposed a solution using a star algorithm. However, a star has one critical weakness: its memory command grows exponentially, making it impractical at real-world scale. Our research fills that gap. We propose IDA as a replacement that is far more memory efficient while still producing equally optimal answer. Our framework consists of four stages. Stage 1, bifurcated graph, the suspects log S and the task ISP log S star are represented as two groups of nodes connecting lines. H are drawing between temporary correlated events. Stage 2, Windows matching delta T 2 seconds NTFS purpose and SQLite Firefox purpose use different clock that can differ by up to 2 seconds, requiring exact time match produce 100% anomalies. No investigative value. The 2-second window resolving this. Stage 3, MChess partition. Even with no match in the ISP log standalone as singletons, immediately suspected as deliberately delete events. Step 4, IDA stars research using admissible heuristic h of x equals scaling of mx minus 1 divided by 3, guaranteeing optimal solution. The dataset we use is from Zenodo, a public forensic dataset based on Plaso, the de facto standard in digital investigation, selected because it's the only one with verified ground truth from real user activities. Scenario test, scenario 1, someone using Firefox to search for SQL injection attack, totaling 16,007 events across 7 activities space. We considered 3 logs, artifact log V, the original, 16,000 event log as ground truth, log U, the ISP log with 110 browser event as trust reference, and log V prime, the log we falsified the deliberately deleting 15 events. The 15 events delete represent only 0.09% of the total log, nearly undetectable by ordinary check. Of 3,883 browser event in the suspect log, 2-second windows matching confirmed 39.3% as normal and 70.7% is anomalous. Compared with exact match without time tolerance, 100% anomalies. Now investigative value. The 2-second window transform this into a meaningful split. From the first breakdown, first state dominate at 53.1%, US and journal 37.8%. Most legal important is perfect, only 14 even, but proving that Firefox was actually executed by the suspect. This is domain comparison. A star versus IDA star. In Nodes Explorer with M verified from 4 to 10, both algorithms always produce equally optimal solution. Move equal to 1 across all M value, the difference lies in memory efficiency. At M equals 4, a star explores 2 nodes, IDA star only 1. At M equals 10, I star 21 nodes, IDA star only 8. The ratio increased from 2 times to 2.6 times. This is consistent with theoretical prediction. A star recurs OB to the D exponential, while IDA star requires only OD linear. For real logs with M in the hundreds to thousands, the IDA star events span several orders of magnitude. Of the 15 deleted events, 9 were successfully detected. Recall 60%. Most important, all forensically critical events were found. The Firefox.exe, perfect entry profit program execution, and the change to entries proofing web access. The six undetected events are low-level USN journal entries that simply do not appear in the ISPS log. This is not an algorithm failure by design. ISPS do not record the file system level. Limitation: experiments were limited to M maximum 10 and a single delta T. Future work will be evaluated at M50 to 500 and on real case data. Conclusion and contribution. 3 key contribute of this research. First, delta 2 second Windows matching resolve timestamp heterogeneously from 100% anomalies to a meaningful 39% to 61 split. Second, IDA star proven to 2.6 times more memory efficient than A star without loss optimally. Third, 60% recall with all critical evidence successfully detected. The method is rule-based, transparent, and auditable in court. That concludes my presentation. Thank you to LPDP to support my through the equity program and to all supervisors and collaborators. Thank you. Okay, thank you, ma'am.
Are there any questions?
We can move to next.
All right. So our next presentation for today will be by Akshay Ladha, who will be presenting Intelligent Auto Reply System for Twitter using Kafka, Spark, and LSTM. Akshay, you may now begin.
I'm sorry to interrupt. I want to tell you, my abstract in my paper and the website, it's different. Maybe from the admin can fix it. Thank you.
Yeah, could you please write that in the chat box? We'll fix that right away.
Okay, thank you.
So my screen is visible. Hello.
Yes, it is.
Okay. So good morning, everyone. I am Akshay Ladha, currently pursuing my MTech in cloud computing. Today, I will be presenting my project titled Intelligent Auto Reply System for Twitter using Kafka, Spark, and LSTM. This project focus on like building a real-time and scalable customer support system that not only automates response but also ensures like that the response are reliable by using a confidence-based decision mechanism. So let's move to the next slide. So I will be first explaining the problem we are trying to solve, following by the limitation of existing research. Then I will walk you through our proposed methodology, system architecture, and implementation detail. And finally, I will present the result discussion and discuss the scope of the project and conclude with the key takeaways. So let's move to the next slide. So this is my introduction. Like social media platform like Twitter generates a massive number of real-time customer queries every second. Handling these queries manually is inefficient and time-consuming and not scalable for organization. Although automated system exist, they often generate response without checking the reliability of their prediction, which can lead to incorrect or inappropriate replies. To address this issue, our system processes tweets in real time using Kafka, Spark, and uses LSTM model to understand sentiment and classify complaints. And most importantly, we introduce a confidence-aware mechanism that ensure only reliable prediction triggers automated response. So thereby like improving both the accuracy and users' trust. Let's move to the problem statement. So like traditional customer support system, I either rely on the manual handling or basic automation. So both of which have significant drawbacks. Manual system lead to delayed response and higher operational cost, while automated system often respond incorrectly because they do not validate prediction confidence. So additionally, these systems struggle to scale during high tweet volumes. So the core problem is that existing solutions do not incorporate any mechanism to evaluate whether a prediction is reliable before responding, so which ultimately reduce the customer trust. So this is my literature survey. So like from the literature survey, it's clear that the most of the existing research focus only on the sentiment analysis using machine learning or deep learning techniques. Many system operates on base data rather than the real-time streams and do not support like continuous data injection. So and they lacks like automation, response generation, and do not consider prediction confidence. So in some studies, they mainly focus on model comparison, while other emphasizes like feature extraction, but none provide a complete end-to-end systems. So this reveal a real research gap there, that there is no integrated system that combine like real-time processing, intelligent classification, and confidence-based decision making. So now let's move to the proposed methodology. So to address these limitation, we propose a complete real-time pipeline. So basically tweets are first collected using a TWP API and streamed through Apache Kafka. And the Apache Kafka structure like streaming process these tweets in the real time. Then LSTM based deep learning model classify the sentiments and identify complaint category. And the most important component is the confidence awareness decision mechanism, which use prediction probabilities to determine whether a response should be generated. So if high confidence prediction trigger like if the confidence prediction is high, it's directly automates the replies, while low confidence cases are either handled consciously or sent by manual reviews. So this is my system architecture. So basically, this represent an end-to-end pipeline designed for the real-time processing. So initially, like tweets are collected to the by the help of TWP API. Then after that, Kafka act as a streaming layer to ensure continuous and fault-tolerant data flow. Spark like process the data in real time, enabling low latency analysis, and the LSTM model then performs sentiments and complaint classification. After this, confidence score is calculated using softmax probability. So based on this score, the decision engine determines whether to generate a response or not. So if approved by the system, directly sends an automated reply along with a unique ticket ID. So this architecture ensures scalability, efficiency, and intelligent decision making, making it suitable for the real world deployment. So this is my implementation. So the implementation is mainly divided into the 4 major modules. The first module handled data injection and streaming using TP, Kafka, and Spark. The second module focuses on pre-processing and feature engineering, including text cleaning, tokenization, and word embedding. The third module involves LSTM-based sentiments and complaint classification. The fourth module implements the confidence-aware decision mechanism and integrate like Flask API for generating real-time responses. So all these modules work together seamlessly to provide continuous and efficient processing. So now let's move to the next slide. So this is my novelty. So mainly the key novelty of this project is the integration of a confidence-aware performance layer within a real-time NLP system. So unlike traditional approach that rely like solely on the model prediction, our system evaluate the confidence of each prediction before taking action. So by using softmax probability score, the system ensure that only high confidence prediction result in automated replies, and the low confidence cases are flagged for the review instead of being executed blindly. So this approach significantly improve the reliability and reduce the risk of incorrect response and make the system more suitable for the real world application. So this is my data set details. So for like training and evaluation, we use the A-line Twitter data set, which contain over 1,14,000 data. The data set include attributes such as tweet text, sentiment levels, and complaint category. And we implement an NLP processing pipeline that perform text normalization and stop for like removal, noise filtering, and the processed text is then tokenized and converted into the numerical sequence using word embedding, so which serves an input to the LSTM model. So the data set is split into the like training and validation set, and performance is evaluated using matrices such as accuracy, F1 score, latency, and throughput. So this ensure both model effectiveness and real-time performance. So now move to the result part. So like this result demonstrates the effectiveness of the proposed system. A real-time tweet is successfully processed and the system correctly identify the complaint category and sentiments. Based on this analysis, it generates an appropriate appropriate response along with a unique tweet ID. You can see, and for tracking and for the backend logs show that the entire process from the tweet injection to the response duration occurred in the real time. So this validates the system ability to perform end-to-end automation with low latency and high accuracy. So this is the scope of the
Sorry
project.
to interrupt, you have a minute left.
Okay. So this like main scope of the project, like the same framework can be applied to the social media platforms such as Instagram, WhatsApp, and Facebook. So it can be enhanced by integrating advanced NLP model like Transformer or GPT. So, and finally the conclusion. So in the conclusion, we have developed a real-time scalable and intelligent customer support system by integrating Kafka and Spark. So we achieved efficient streaming processing, and the LSTM model enabled accurate sentiments and complete classification. So most importantly, the introduction of confidence-aware decision mechanism ensure reliable and safe automation. So this makes the system not only efficient but also trustworthy and practically for the real world deployment. These are my references, and thank you.
Please go back to references. Akshay. Akshay, I'm audible?
Yes, sir, yes. So these are my references.
Next page. Okay, I'm not asking any question, but just a suggestion. In your reference, there is no 2025 journal publications. You have only two paper from 25, and I think both are from conferences.
So
Whenever you are doing any data set based project or any kind of work, please focus on recent research, because this kind of work I have seen multiple times in 2025.
Okay, sir.
Just a suggestion for you.
Okay, sir. Thank you, sir. Thank you for the suggestions. So I can stop.
Yes.
All right. Moving on to our next presentation, we have Savitri S, who will be presenting Modern Investment Curiosity and Financial Decision Making, an empirical study of college teachers in Kerala, India. Savitri, you may now begin.
Yes, I am audible.
Yes, you are.
Please wait. I am sharing my screen. Um, can you see my screen?
Yes, we can.
Good morning. My name is Savitri, and today I am going to present the topic Modern Investment Curiosity and Financial Decision Making, an empirical study of college teachers in Kerala, India. And I am presenting this paper on behalf of my co-authors Pravita N. Iyer, Sri Lakshmi S.R., Dr. Valsala Chandran K. from Department of Commerce and Management, Amrita Vishwa Vidyapeetham, Amrithapuri, Kollam, Kerala. And our study is mainly focused on one question: why do educated and high qualified teachers are not are still away from modern investment opportunity, like options like mutual funds, shares, etc. And we found that the result always lies on one sociological factor called curiosity. Let's get started. um, Savings and investments are very important for an individual financial security and for economic development. And in our study, college teachers occupy a unique position. Like, they have stable income and they are highly educated. Despite postgraduate and doctoral qualification, teachers prefer traditional investment options like bank deposit, fixed deposit, rather than the um, modern investment modern investment options like mutual funds and share. And the existing study concentrate on urban professional, industrial workers, or agriculture household. The educational sector remain comparatively neglected. Like, this paper investigate both demographic attributes and a novel psychological construct, modern investment curiosity, as determinant of saving and investment behavior. Um, and uh, while reviewing the existing literature review, we have found four gaps in it. Like, literature review only focus on demographic factors and not ignoring the psychological mechanism, like the interest and curiosity of a person to invest. And the second one is, most Indian studies are mainly focused on metropolitan investors or institutional settings. And the third one is, educator in small urban centers, example like Kollam, Kerala, are virtually absent from the empirical record. Financial awareness, risk preference, and behavioral studied is in isolation. Integrated framework are rare. And the main contribution of this study are it introduced modern investment curiosity as a measurable factor. And the second one, it combined both demographic and um, behavioral variables within one framework, and target college teachers in Kollam district, meaningful but overlooked middle income segment. And it validates curiosity scale and test its predictive power empirically. And the main objectives of the study are, first one is demographic association, like it determine whether the demographic characteristics like age, income, marital status, family, disability affect saving behavior. And the second one is to know the effect of investment curiosity. And the third one is in theoretical integration, like examine whether observed pattern align with prediction from life cycle hypothesis and theory of planned behavior. And the fourth one is to provide valuable insight for financial literacy designer, educational administrator, and housing finance policy maker. And the study's central construct is modern investment curiosity. It means like a person interest in learning and in learning and understanding about new investment options like equity, mutual fund, digital platform, as distinct from the conventional channels like bank deposit, postal savings, gold, etc. This curiosity is based on three parts, like modern investment curiosity. Like first one is financial openness, then information seeking and exploratory tendency. Like in financial openness, it is the willingness to consider and adopt non-traditional investment instrument beyond familiar channels. And in the second one, the information seeking, it proactivate search for knowledge about new invest in financial products, return and market developments. And the third one is willingness to explore, like intrinsic motivation to experience unfamiliar options. And here one difference is there, like in investment curiosity is conceptually different from financial literacy. Like literacy is mainly the knowledge, like a curious individual may have modern knowledge but moderate knowledge but have strong exploratory drive, while a knowledgeable person may lack curiosity and remain within the established pattern. And the theoretical framework. This study is based on two theories, like life cycle hypothesis and theory of planned behavior. Like in life cycle hypothesis, like it means like earn during their people save during their earning years, like mainly for their retirement, like for children fund, etc. And while considering, so in a study, the mid-career teachers like 30 to 51 ages expected to show highest saving engagement. Like this is the time they were save more. And coming to the theory of planned behavior, and behavior depend upon attitude, social pressure, and confidence. Like a teacher who is more curious about new investment opportunity, they show a positive attitude and feel more confident in investing in modern investment options like mutual funds and shares. And coming to the research methodology, we have used research design like descriptive quantitative design, and it uses a cross-sectional survey approach. Primary data is through a structured questionnaire, and we took around 4 weeks to complete the process. And SPSS is used for descriptive and inferential analysis. Like the sample profile, we collect 145 complete responses, and mainly from Kollam district, Kerala, from government aided and private colleges. It is use a purposive and convenience sampling. And from the sample profile, we can see that 55% of female and 45% male respondent and 40% hold doctoral qualification. Like data collection is through an anonymous electronic questionnaire through WhatsApp, Telegram, and directly, and faculty network across various institutions. There are three sections in that data collection, like demographic, behavior, and curiosity scale. And mainly the Cronbach alpha is 0.7. It shows that the acceptable reliability.
I'm sorry to interrupt. You have 1 minute left.
Sorry, ma'am. And there are six main variables we collected during the study, like demographic, family variables, disability status, saving behavior, investment behavior, and investment curiosity. And based on this, we have created four null hypotheses. Like hypothesis one is between saving and household size, and hypothesis two is between the savings and disability, and hypothesis 3 is between curiosity and investment behavior, and third one is curiosity and marital status. And while considering the hypothesis testing result, we can hypothesis 1 and hypothesis 2 are accepted, and hypothesis 3 and hypothesis 4 are rejected, because in the first one it show a p-value in saving behavior and household size. It shows a p-value of 0.54, which is less greater than 0.05. Like means we have to accept the null hypothesis. And the hypothesis two is mainly about saving behavior and physical disability. Like the p-value is greater than 0.05. It also, the null hypothesis is accepted. And the third hypothesis, the investment curiosity and the investment behavior of a teacher, like one who is more curious will invest in more advanced modern investment option. And this hypothesis is the main key important thing in our project. And the hypothesis 4, it show a significant p-value of 0.22, which is less than 0.05. Like we will reject the null hypothesis. Then the practical implication is like by providing a financial literacy program and institutional curiosity building, like conducting a discussion section in college, and by providing giving giving people like teachers, to encourage teachers to explore more investment opportunities, and by providing personal financial guidance. And our conclusion is like it is divided into four parts, like empirical contribution, like the first study to operationalize and empirically validate modern investment curiosity among college teachers. And the second one is theoretical integration, like life cycle hypothesis explain about saving quantity, and theory of planned behavior explain instrument choice, and the demographic nuances, that marital status, incomes, age associated with financial pattern, household size, and disability do not have a relationship with the that of professional norms. And the societal significance, by improving the educator financial well-being, we can improve like a they can act as a financial ambassador for students, that is a future generation. And mainly the limitation of the study, it is limited by cross-sectional design, and a small sample is collected for study and self-reported data, and it need more further validation for curiosity scale. And for future research direction, I can say it can be used for longitudinal studies and multi-state study. And by using more advanced statistical tool, we can study relationship in details. And fourth one is like experimental study, and fifth one we can extend to other group. Like this study is mainly focused on teachers, like we can include employee, other, etc. Thank you. Hello.
Good morning, Savitri.
Good morning, sir.
As I see, you have only 145 responses.
Sir, they have shown that by testing the scale, it is Cronbach alpha shows 0.72. Like it is acceptable, right, sir?
Total people who give you the response was 145.
No, sir. Like more than that, I have get, but the 145 only the correct we have taken. Some partial responses we have uh,
Total
did
how, total how many responses were there?
total around 150, 160, sir.
So do you think 150, 160 is a sufficient data set to go for any conclusion?
No, sir. I have told in my limitation, like the sample size is less. Like,
Uh,
hello?
okay. Next time, whenever you go for any kind of research, please find
Okay,
out
sir.
the minimum responses required to validate. So, as any financial data, and if you are going for any district only, so minimum
Mm,
response required is 300.
300, sir. Okay, sir. Next time I will check with that, sir.
Oh, thank you.
Thank you, sir.
All right, so now we'll move on to the next presentation. Next up, we have Ayushi Raj, who will be presenting risk adaptive and change aware backup optimization for sensitive data using reinforcement learning. Ayushi, you may now begin.
Yes, ma'am. So, uh, good morning, everyone. My name is Ayushi Raj, and I'm going to present on the topic risk adaptive and change aware backup optimization for sensitive data using reinforcement learning. So, introduction. First, we'll see the introduction. So, there is a huge growth in sensitive data, especially in healthcare systems. Traditional backup systems use fixed policies which do not adapt to changing data conditions. In uh, in cloud environments, data is continuously changing, and not all data has the same sensitivity. So, using the same backup strategy for all data either waste storage or risk security. To solve this, we propose a risk adaptive system that uses reinforcement learning to make intelligent backup decisions while ensuring privacy. So the main causes, main problem, main problems were that the existing backup system uses fixed schedules or thresholds. They do not. Consider important factors like data sensitivity, risk level, uh, or how frequently data changes. Because of this, they either perform too many backups, increasing cost, or too few backups, increasing risk. So, and also these systems are not intelligent and cannot adopt over time or learn from its um, previous backups and all logs. So we need a system that can dynamically optimize backup decisions while maintaining security and reducing cost. The objective of this research is to design an intelligent backup system that can adapt based on real-time conditions. We consider factors like sensitivity, risk, and data changes. We, I have also integrated deduplication, encryption, and hybrid cloud storage to improve efficiency and security. And also, I have used reinforcement learning so the system can learn the best backup strategy over time. Now, this is the system architecture or of reinforcement learning based intelligent backup decision framework. So here the system follows a multi-phase pipeline. First data is loaded and cleaned, then a temporal replay engine change-aware temporal replay engine simulates how data changes over time. Then a risk model calculates the risk score based on the sensitivity and changes. Based on this, the system decides backup strategies using static, dynamic, or reinforcement learning-based model. Then after deciding when to backup, we apply deduplication to remove redundant data. Then encryption is applied to ensure privacy. The system decides the system decides where to store the data using hybrid cloud placement, that the data should be stored on premise or in private cloud or a public cloud. It will decide. Finally, the backup is executed and logged for analysis. So now we'll see the stepwise implementation and stepwise implementation. So first I've taken data set and we start with sensitive healthcare data. I've taken this data set from mimic 4 clinical data set which consist of the data of hospitals and ICU records, this is a metadata provided by metadata of clinical data set. So the data is first passed through a data ingestion and cleaning phase where we handle missing values in standardized formats like timestamps. Then we perform temporal replay engine. So the clean data is processed by a temporal replay engine. This component simulates how data evolves over time by dividing it into time steps. This is important because backup decisions should depend on how data changes, not just static data. After that, we calculate a dynamic risk scoring using a sensitivity and risk profiling engine. The risk is computed based on the 3 main factors, that is data sensitivity, change frequency, and data exposure. So this risk score is very important because it guides the backup decision. Then now this risk information is given to the reinforcement learning based backup decision engine. Here we use reinforcement learning to decide whether to skip, delay, or perform backup. Unlike traditional systems, this model learns from past decisions and improves over time. Now if the system decides to skip, no backup is performed, only metadata is updated, so there is no storage cost. If the system decides to perform a backup, then the process continues to the next phase, which is deduplication engine. So first we apply sensitivity of aware deduplication. This removes redundant data while ensuring that sensitive data it ensures that sensitive data is handled securely. Then after deduplication, we apply encryption using secure methods, using a secure method like Fernet. This ensures that sensitive data is protected before storage. Importantly, this is done using metadata simulations so that raw data is not exposed. Now the system decides now the system decides where to store the backup using hybrid cloud placement. Depending on sensitivity and cost, data can be stored stored in on-premise or private cloud or a public cloud. So highly sensitive data is restricted to safer storage option. Uh, it is restricted to safer storage option. Finally, lastly, all backup decisions are logged in a decision locker, so that it can generate a so that the system can learn from this from the logged data and improve itself for the further backup decisions. So overall, this decision this system decides when to backup. It reduces storage cost and also ensures privacy and adapts dynamically using reinforcement learning.
I'm sorry to interrupt. You have a minute left.
Okay, ma'am. So this is this graph shows how risk show how risk exposure fluctuates over time as a clinical data changes. So the static method produces frequent high risk spikes uh, because it backs up data blindly. The reinforcement learning model reduces these spikes by learning when not to perform unnecessary backups. Then s- this this graph shows storage efficiency. Static has high redundancy, which means inefficient storage, but reinforcement learning achieves the lowest redundancy with better deduplication and efficient storage usage. And this graph shows the trade-off between cost and risk. So static has low cost but very high risk, and reinforcement learning achieves the lowest risk with reasonable cost and giving the best balance. So in conclusion, I have developed a risk adaptive backup system using reinforcement learning, and the approach reduces storage usage while maintaining privacy and security. Compared to traditional methods, it achieves lower risk and better efficiency. Also, since it is a metadata driven, it is suitable for sensitive domains like healthcare. These are my references. Thank you.
We can move to next.
All right. So now we'll be taking our last presentation for today. Now we'll have Ritesh Kumar Verma, who will be presenting
ma'am.
an adaptive
Yeah,
retrieval augmented customer support agent with learning to rank using Azure ML and OpenAI. You may now begin.
Now, my screen visible, ma'am?
Yes, it is.
Yeah. Thank you, ma'am. I am Ritesh Kumar Verma from SRM Institute of Science and Technology. Today, I am presenting our work, an adaptive retrieval augmented customer support agent with learning to rank use Azure ML and OpenAI. So firstly, I will move in the part of agenda. There are several steps. Like first one is introduction, problem statement, motivation, and next one is proposed system, core novelty, result, purpose, impact, and conclusion. So in the first slide, in the part of introduction, basically this work focus on improving customer support automation using AI, and traditional system struggle to handle like a large number of queries efficiently. To address this, we create an intelligent system based on RAG, which combines information retrieval with large language models to provide accurate and context aware responses. So in the next slide, In the part of literature review, in the first paper, yes, right. in the first paper, like he uses fuzzy based similarity search, but the main limitation is lack of integration with generative models like GPT. And in the next paper, they implement RAG, but high computational cost of for real-time responses. And in the next paper, they uses GPT models, but the total dependency on fine-tuning data. Mm. Can I say it again? I think some problem. I think internet issue. Wait. Wait.
Uh, Nothing audible
Wait.
to me.
Wait. Yeah. And in the next slide, they uses a GPT model, but lack of domains like specific fine tuning example. So there are some gap of the existing models and my models. And in the next part of problem statement, like existing customer support system faces major challenges such as poor semantic and understanding, high response latency, and inefficient ranking of result. So in most track systems rely on a single stage retrieval, which often returns irrelevant or noisy information. Additionally, we can use high dependency on LLM increases computational cost and delays. And in the next slide, motivation, the motivation behind this work is to build a scalable and intelligent support system that understand user intent better, retrieves relevant information efficiently, and generate accurate responses. So the main aim of this model to reduce latency and improve ranking quality, which can easily enhance overall user experience. And in the part of proposed architecture, like our system follow a hybrid rack architecture. It includes embedding generation, fuzzy based retrieval, core encoder re-ranking, and lambda bar marking. These components work together to improve the relevance of retrieval results before passing them to the language model for response generation. And in the next slide, like implementation, this system is totally implemented using Azure OpenAI for embeddings and response generation, Fuzzies for fast similarity search, and Azure is used for machine learning for deployment. And cross encoder model basically used for re-ranking, and lambda bird optimize final ranking scores through learning to rank techniques. And in the part of core novelty, in the part of core novelty, the key novelty is adaptive hybrid ranking within the RAG pipeline. Instead of relying on a single retrieval stage, we apply selective re-ranking and learning to rank method. This reduces unnecessary LLM calls and improve accuracy and enables latency aware optimization. And in the part of data set, I uses 130,000 customer e-commerce customer support query response. And there are four features of my data set. First one is instructions, second response, third category, and fourth one is intent label. And in the part of result and performance of my project, our result shows significant improvement in the both latency and throughput. The proposed system reduce response time while maintaining high accuracy. Additionally, optimize ranking improves the relevance of responses, leading to better performance compared to baseline rank systems. And this is a user interface of my project. And the next slide is purpose and impact. The purpose of the system is to enhance customer support efficiency by providing faster, more and accurate responses. It reduces operational cost and improve scalability and increases customer satisfaction by delivering intelligent and context-aware solutions. And in the last part of my conclusion, um, the proposed systems successfully integrate retrieval, ranking, and generation techniques to build an efficient AI-driven support system. It addresses key limitation of existing approaches and reduce the cost of model and decrease the latency and increase the scalability. And the last one is I use 20 references in my project. Thank you.
No question from my side.
Okay, sir. Thank you.
All right. In that case, we'll move on to the closing remarks. Just give me 1 second. So I would sincerely like to thank all of our authors for their excellent presentations and their contributions to this session, and all our participants for being a part of this international conference. I hope this session was informative for everyone, and on the behalf of the entire team, I would like to thank you for your support during the 11th version of this conference and all the previous 10 versions. We hope to have you in the 12th version as well in 2027. All the presenters will be receiving their certificates via email within the next 2 working days, and the publication will be live in 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. I would also like to thank our session chair, Dr. Sanjay Agal, for chairing today's session. And on behalf of the entire team of ICTIS, I would like to present this token of our appreciation. Thank you for your valuable presence, sir. And I kindly request everyone to please switch on your cameras for a quick virtual snapshot of the event. All right. Thank you so much, everyone. You may now leave. The session is adjourned.